Welcome to a new test and teardown video. This time it's another Brüel Kjær from Denmark. It's the bandpass filter set 1612, and I got the extension filter set type 1620. So there's a huge extra box with this special Brüel Kjær connector. And this one you stick in the back of this filter set. This filter set can of course be used without the extension filter set, and it says here at the front, the extension filters, they will be enabled at those three settings. Click, click, click. So that will give you 12.5, 16 and 20 hertz. So 3 extra steps. Normally it starts at 25. So we have different settings here, and that is, see, 25, 31.5 and 40, see? And then there's another one up there. So this is because of this switch over here, where you select if you want the octave 10 dB, or you want a third octave. So that gives you 3 extra steps. We also have a external battery on and off. And this says here in Danish, you need to remember to turn it off when you are not using it, because there's a tiny little transistor amplifier to make up for the gain loss in all the filters and all that kind of stuff. And we can change the input to be direct or using a transformer. And then there is some sort of a awakening network for normalizing the levels. And I bet there will be a million trimmers in here. You can turn this on and off and then activate the level trimmers. I spent the last 2 hours polishing and washing and making it nice and shiny and beautiful and presentable for the video. So now it looks nice and clean almost. You can see a little bit of dirt here, but it was of course really, really old and dirty. There's a nasty dent here I can't get away. And there's a funny red undercoat. So this is a little bit annoying. I really love stuff to look as nice and clean and new as possible. I can also say I found the schematic of this unit, and it says 1953 to 1964. We got some different revisions, and they were really nice to put the different year codes and all that kind of stuff in it. In the schematic, so I should definitely show the schematic. It says in the schematic we got 50 positions. This switch that selects all the different filters, and we can see all the different coils and resistors, and we can see the little transistor amplifier. I should maybe... Oh, this goes really, really nice and smooth. Here we can also see that it's selecting some pre-selected filter. This is linear, that means no filters. So this way you can calibrate your through level. Here at the back, pooh, that was yeah, they're really heavy. So here at the back we got this little remote control connector, and I don't know, it's not looking super professional, maybe there was a nice, beautiful box around this, and maybe it was hanging somewhere. I don't know, but this is just how it looks. So this is how you power it on, and you can of course remote control a through relay. There's a little relay in here. You can activate that one, and this is the connector for this extension filter. With, I don't know, can we get some light in there? That's difficult. I think those connectors are a special Brüel Kjær connectors, so you can't really get mating parts for these from anywhere else besides Brüel Kjær, by the way. Yeah, we should definitely open and inspect. It could have been fun to know what was the original sales price for this unit back in the 50s or 60s. I mean, this is something. And we already talked about the 50 steps on the switch, and that is the switch in here. I don't know exactly what is going on. We can see the tables falling a little bit apart in here, but I guess we can't see the switch like really how it's done. Got a lot of grounding here, all those shielded cables, and I bet it's switching some sort of a binary decimal format or something like that to save the number of wires you need to activate the different systems or something like that, right? At least you select one of these. So we got 12 sections, and in each of these 12 sections you got either 4 or 5 filters. So you go here and then 1, 2, 3, 4, or 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, and so on. And this is the way you get through all the different filters. Over here, I guess you get a lot more. It of course depends on the frequencies. The higher the frequency is, the more you can have in this space. I can't really take them apart because this is like welded together into one solid piece, and the same with the bottom plate here is also welded. And I'm not going to pull out these individual sections because you need to desolder all sorts of wires, but I can show a little bit of a view. You can see all the big inductors, and then on top here we got a lot of different capacitors. So I think we got 5 capacitors here, and we got only 3 in that one. So that is probably the lowest frequency. And then, I don't know. Yeah, up here we got a lot more capacitors and inductors behind it. See, also we got a lot of trimmers, and that is for all the different levels for each of the different bands. I mean, I am completely in shock about how beautiful this is. And it's insanely heavy. And it's just built exactly how it should be done. Look at those little shielded, isolated plates. And they're a little bit weird to touch. There's a thin layer of some nastiness. See here, I tried to clean it away, and also up here I was able to clean it nice and fine here, but there is a thin layer of some sticky, nasty feeling. And I think this is a little motor or a solenoid that is for the remote control, because there is a way to step. So this is the manual. But I bet this one can do the click, 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 change something. Maybe I should try and put in some, power this up. See, there's a little diode here. So this reveals exactly the voltage and all that. I can of course just look it up. It's no big secret. I got the manual and schematics and everything, but it's more fun just to poke around with it. And here is the little amplifier, a 2 transistor amplifier with some diodes and a few capacitors. And we also got the transformer, so it's a 1 to 10 impedance transformer, and we got some different capacitors for the different frequency ranges stashed up here. And that is more or less what there is inside this box. So I was of course consulting the manual about the remote control voltage. So this solenoid needs 24 volts to operate, and then it should step everything around each time you apply power. And it says it's supposed to use about 180 milliamps, and it's using 200 milliamps at 24 volts, but nothing is moving. So I need to try and pull this apart because I really like this remote option to work, and it could be a really cool thing to have up and running. So I will try that. I'll just remove the wires and remove the screw. So now I can move the solenoid, but look, now I can simulate. See? So this is how it should be moving. So this one should move to the left. So I'll just try and mount it like this and then see if it can move. So to get this solenoid out, we need to remove this one. And look at that, it's made non-symmetric, so it can only be assembled one way. And then there is this, the knob. You can just take this off, so this is not important. But then there is, of course, this indicator. So I put this indicator exactly in the middle of this little globe. And then I will remove this screw and pull this out and unscrew these and take out the scale. And then I will get access to the solenoid. And there you have it. I, of course, added a little cheat mark here so I can put the indicator back. But here's the little gearbox. And we can now see this is the screw that I need to handle to be able to pull out the solenoid. So I ended up taking this entire solenoid assembly to bits and pieces, and I ended up getting lubrication into the solenoid shaft and bearings. And see here, I made a little drawing. And let's see what happens if I give it 24 volts. See? So now it's moving the dial every time you give it a little pulse. Isn't that just cute for a remote control? Hey! So funny! I love it when I can get stuff to work again. So let's try and test this thing. Look at that! After a little bit of poking around, this is 1000. My input here is 1 kilohertz and the output here in scope and all that. I don't need to explain that super much, do I? But we're now in 1/3 octave. So that means it's each little step up here that works. So this is 1000, then 800, and then 1250. So all that works. Let's go down here and let's try the 10. So this is octave. This means we got all those 1, 2, 3, 4, 5, 6, 7, blah, blah, blah. All those octave. And then they're all the same, more or less right? And then we can go to 2000 and then it's gone, okay? So I believe it actually works. Let's try and put it into exactly 2000. Let's dial the frequency. Doodly doodly doot. 2 kilo. And again, see, they're all the same. And if we go here, we hit the higher Q. And then it's, so this should be 1600. And there you have it, 16. Oh, it's the same level for 16 and 1700. And then it's gone. 17, 16, 15, 14. Okay, so it's a little bit, it's of course, yeah. It goes up and then it's flat at the top and then it goes down. So this is perfectly fine. So it should be 16 is the sets, huh? Here you go. Wow, this is really, really a nice filter. I totally like it. So you can easily sweep some stuff and yeah. Could be really, really fun to put some music through this one and then listen. And then you can really, really easy pinpoint exactly where's the vocal and where's this and this sound in the frequency spectrum. I mean, I'm gonna have so much fun playing around with this thing. I think it was this. So there's a transformer or a direct. Yeah, this switch is definitely bad. I want to try and see if I can clean it a little bit because see, now it seems to be working. Yeah, this is typical, but before it just needs a lot more use. Then it's gonna be fine. This is of course, now we turn it off and this is the amplifier going to deep sleep. Of course, this amplifier is not using a lot of power. As you can see, this is now running off the decoupling capacitors. It's just running on one single 9-volt battery, and that should be the levels. We should also try the linear mode and see. This is my, oops, hello. So that is not, okay, so you need to turn on this. Then you have linear mode. That is the level. And then you can go to 1600, and there you have that one. Great. Now I really want to try the external filter. We should be able to do 25 Hertz with the built-in. So this is 25 Hertz. So that works. Of course, if I go down to the extension filter, then nothing comes through. So this is perfectly normal. And then 31. So there's a good selectivity also at the really, really low frequencies. This is absolutely amazing. It just really works. And here we go. This is when I turn this off. Then it kind of splatters the filters together. How cool is that? And we also need to open this extension filter. I want to see it inside, right? I'm running out of room. Okay, so now we're back. I got 25 Hertz in. Extension filter is turned on, and then I go to 20 Hertz. And then let's set the frequency for 20 Hertz. No. No. Why don't you work, you damn So let's try 16. Bummer. So why is this not working? Is it this connector? No way. Okay, so that is just how it is. The 12.5 is also not working. Let's go back to 25. And 25 don't work. Okay. So it was maybe my cable here. So I got dodgy cables all over the place. Damn. What a demo is this? Let's go back to 20. For crying out loud. No, it is not working. It's not me who's... I may be silly, but this is definitely not working. So this is 16. Okay, let's try 63. And then it works again. Yeah, there you have it. So my sexy external extension filter set is just garbage. Maybe it's I don't know, full of rotten something, I don't know. But we're gonna open and have a look anyway, aren't we? I guess there is some sort of an official connector protector. When you're not using these type of connectors, you can see how fragile the pins they are, right? And of course we can have some broken solderings in here. There's a tiny little screw there, and there's a way to open this and all that kind of stuff. So I just take a piece of cardboard and wrap around like this a few times and give it some gaffer tape. I mean, this could work, couldn't it? And this way I can protect those pins when I'm poking around with this, I guess. And it's also good for transport protection. Yeah. Gaffer duct tape. That was real weird. Normally you just remove those little screws here from the back, and then you can pull out the entire thing here, but here it's done differently. This is also the way, but you need to remove those screws as well, and then you can pull out the filter. Really? It's just amazing. Now you can see those filter inductors, and I bet that we got a gazillion million windings in these, and then all those capacitors. And this is only one filter for 12.5 hertz. Then the 16 and the 20 hertz. Yeah. This is something. So I'm looking for a broken wire or something that could explain why none of these filters are working. And we got this little rubber feed through, and this is the way it is. This looks a little bit like, how are you doing it? Maybe it was supposed to be like that, I don't know. But that is just one beautiful filter, and we got that many sections with all those wires that goes here from the inductor. Some they are not in use. So they go up and back again. Now those are in parallel. No, they're all in parallel to adjust the value. And then some resistors to fine-tune something. What do you think about that? Oh man! Unfortunately, it just don't work. But there's definitely a very simple explanation for that. Here we got all the wires that connects to everything else, and maybe I should try and zoom in a little bit on this one here. Look at that, see there's a white just like the others, and here on the other side it is definitely connected to all the coax cables, so that definitely is an important signal. Okay, let's look again. Here is a little beepity beep. So if this one is connected to this one, right? And then I take all the different pins in the connector and then check none, no contact. So is it up here in this soldering up here, or is it in here? I think there is a way to get into these. It's not super easy, by the way. So this you can just unscrew. But I don't know where it is. This is where it is. Look at that. Here's this disconnect. Because this cable here is a special high impedance coax, and it's sort of soldered into a little holder thing here that will always break. So what I want to do is I want to solder like a really thin but super flexible wire, and then it's going to work. It's not rocket science, is it? This looks like somebody a little bit dodgy soldered this. I mean, this can't be original, because this is not the kind of quality you see. Well, what is this kind of Muppeteer soldering here? I'm not super happy about how those pins they are bent, but they kind of mate perfectly fine with the female part. So, but now I think it's going to work. I don't know exactly what to say about those cables, but anyway, here we got signal again. So this is 63. Let's go down to 25. We know that 25 is an external frequency, so that should work. Now 20, and then we put in 20, and it works. Yay! So if I go to 25, it's weak, yeah, and 16 is weak. So I can put in 16, and we are back. And then I can try with 12.5. That is really crazy. It works. I fixed it. I'm super happy. Now it works in all ranges. Probably. Let's try and check out 40 kilo. It's also working. Here you go. Wow, that is some crazy filter, isn't it? Anyway, I'm super happy to call this video over, done, end of story. And if you happened to get by one of those filters, the 1620 filters, and it's not working, then I would say there is a big chance you could probably repair it the same way that I just did, right? Anyway, bye bye. Please like and subscribe and tell all your friends that will be great.